Now let's start with DC transient analysis. Okay, from the very basic I'll tell you, because transient seems to be a difficult topic. Okay, but it's not so if you'll be able to try to understood this. Now see what is transient. We'll have two terms. One is steady state condition and another one is the transient condition. Okay, in steady state, like suppose I'm giving you one example. You entered the room, this is your room. You entered the room at 8 p.m. and you switch on the fan. Okay, so before 8 p.m., what was the condition? That means the fan was switched off, right? If fan is switched off for a very long duration of time, that is the condition of steady state. Means there is no change in the switch. Okay. But if you are entering the room at 8 p.m., that means at 8 p.m. you are changing the position of the switch. But then that condition is known as transient condition. Transient means changing position, right? Understood? But it's basically steady state and transient. If it is not changing, it's steady state. If it's changing, then it would be a transient. Now the next thing, transient is divided into two category. One is you will get the numerical based on first order, as we have listened it also, that first order transient circuit, right? Another is that is second order. What is the difference in first order and second order? First order means it will have only one energy storing element. Okay, and second order means it will have two energy storing element. So do you know what is one energy storing element? You just studied energy storing element, right? What was that? Inductor and capacitor. If there is a combination of R and L, means one storing element, that is first order. If we are having the combination of R and C, that would be first order, because it is having capacitor only, one storing element, right? Next, if we are having two storing element, means R, L, C, that would be your second order transient response. Got it? So now up to your exam, like your first midterm exam, I think they have in the syllabus of first order transient response, right? So now we'll do the questions based on RL and RC. Later on we'll do RLC. Clear? Now the very next thing, you need to understood the position of switch to understood the transient circuit. What is basically the position of switch? Like suppose they'll give you the circuit like this, a supply and the switch, resistor, or maybe combined with inductor or capacitor. Okay, this is suppose 10 volt, 2 ohm, 3 Henry. They give you the position of switch like this, an arrow. Okay, and they mention that is t equal to 0. So what does this switch indicates? That t equal to 0, the switch is closed, right? If switch is closed, the current will flow or not? Current will flow, right? And at t equal to 0 minus, that is just before the switch closed, that and that condition the switch was open, right? And at t equal to infinity, tell me, like for the very long duration after the switch is closed, then the switch is, it will remain closed. And when there is one more condition, t equal to 0 plus, so in this condition switch is opened, closed, what will be the thing? 0 plus is the condition just after the switch is closed. Okay, just give me 1 minute. Yeah, at t equal to 0 plus means that we are having just after the switch closed. Okay, so in this condition also the switch will remain closed, right? Now I'm giving you one circuit and you have to tell me the switch position. Now in which case, like tell me at t equal to 0, at t equal to 0 minus, t equal to 0 plus, and t equal to infinity. See, at t equal to 0 the switch will be opened, and that means that before that was closed. After that it will remain open and it will remain open. Now can you tell me which condition is steady state and which condition is transient in this? Steady state is when from the switch is very for a very long duration of time. Yeah, and t is less than 0, that is also the steady state, right? And whenever we are changing the position of the switch, that is transient. Clear? Now this is the theory, you can read about it if you want to, that they have given RL circuit, RC circuit, that is the first order circuit. Next they told you about the switches, open switch is closed switch, open switch open circuit, closed switch so short circuit. Okay, so these are the time varying circuit, means it will vary according to the time. Next one is, as I told you, the conditions like this. Now we need to do the numericals based on this, right? There is one more condition which you remember. Again, I'll differentiate between inductor and capacitor. Okay. Like as I told you, from the very long duration of time, the current is not changing in the inductor, right? And for the very long duration of time, voltage is not changing in the capacitor. So we'll have one condition that IL of 0 minus would be always equal to IL of 0 plus. See what happens. As I told you in this circuit, inductor won't allow the change in current, right? So tell me at t equal to 0 minus, how much is the current flowing? The current flowing across the inductor is denoted by IL. So how we will write it, IL of 0 minus. This is the time indication. So that t equal to 0 minus t current is 0, right? So as I just told you, ki current can't change instantaneously. So can we say that IL of 0 minus would be always equal to IL of 0 plus, because there is a duration of only 0.00000001 second. In a very short duration of time, current can't change according to the inductor property. Yes or no? So this is the formula which you need to remember. IL of 0 minus would be always equal to IL of 0 plus. And whenever we need to calculate, we'll calculate IL of 0 minus or IL of 0 plus. No, for the general, we always calculate IL of 0 minus only. Okay. If we need to calculate IL of 0 plus also, then we'll calculate the condition according to IL of 0 minus only. Okay, we'll do numerical, then it would be more clear to you. Now similarly for the capacitor, Vc of 0 minus would be equal to Vc of 0 plus, because capacitor won't allow the change, right? Clear? One more thing which you need to remember, if from the very long duration of a time, means for the condition of steady state, right? Inductor will behave as a short circuit SC. And if for a very long duration of time, again there is a steady state condition, capacitor will behave as a open circuit, right? These two need to remember for the numerical purpose. Now this is they have given C, voltage across capacitor is denoted by Vc of t, voltage across resistor is denoted by Vr of t, supply voltage is Vs of t, current is I of t, right? And as I told that capacitor voltage cannot change instantaneously, so Vc of 0 minus equal to Vc of 0 plus, right? Now can you tell me Vc of 0 minus is how much? This condition in this particular case. So see, in this condition we'll have, if there no current is flowing across it, right? No current means there it will behave as a open circuit, so V0 minus would be 0. So can we say that Vc of 0 plus is also equal to 0? So we need to calculate Vc of 0 plus, right? But we don't calculate directly Vc of 0 plus. If you calculate directly Vc of 0 plus, then will you switch off the, you close the circuit. That would be the wrong answer. That's what I want to tell you. If we want to calculate Vc of 0 plus, we need to calculate Vc of 0 minus always. That would be equal to Vc plus. Clear? You don't need to calculate Vc of 0 plus, you need to calculate Vc of 0 minus always. Got it? Now similarly, the next case, that is of inductor, maybe